Welcome everyone in this NPTEL online certification course on biological process design for wastewater treatment. So, in today's lecture we will continue with the wastewater characterization. In the last lecture we studied regarding the chemical oxygen demand, which is one of the most important parameters if we have to characterize any wastewater with respect to what is the oxygen demand in the aquatic bodies. So, what will be the ultimate oxygen demand when all the organics get degraded, that is always computed beforehand using the chemical oxygen demand as a parameter. There is another important parameter which is referred to as biochemical oxygen demand or BOD. So, BOD is very commonly evaluated in virtually all types of water or wastewater. BOD is a method of determining how much oxygen will be consumed during degradation of all the organic matter present in the water in its natural environment when different types of biological organisms are present in the aquatic system. So, all these biological organisms, they actually use the organic matter present in the water for their growth and their energy needs, and thus they consume all the organic matter. During this consumption, they require oxygen for various activities including respiration and different reactions that happen during the degradation process. Thus, they require oxygen. So, BOD essentially measures the oxygen when the microorganisms are present in the natural environment during the degradation of organic material present in the water itself. BOD itself is considered as an indication of the quality of a water source. So, if we can measure the BOD depending upon standards, we can say that okay, what is the quality of water, whether we can use it for drinking or for bathing or for irrigation. So, different aspects of water quality can be determined using BOD as a parameter. Now, BOD is expressed in milligram of oxygen consumed per liter of sample. Earlier the tests were conducted for 5 days with incubation of all the samples at 20 degree centigrade. However, in the recently the 3 days of incubation is done and the water samples are kept at 27 degree centigrade. So, today we will learn regarding how the BOD test is also conducted. So, that will come later in today's part of lecture. Now, there are during the BOD test there are different stages of decomposition. There are essentially 2 stages of decomposition in the BOD test. In one of them the carbonaceous stage, which is under which the carbonaceous organic matter degradation happens, and then there is a nitrogenous stage under which the nitrogenous compounds their oxidation happens. So, carbonaceous stage represents the oxygen demand involved in the conversion of organic carbon to carbon dioxide, whereas in the second stage or the nitrogenous stage, it represents a combined carbonaceous plus nitrogenous demand when the organic nitrogen, ammonia and nitrate get converted into nitrate. So, nitrogenous oxygen demand generally begins after 6 days. So, it was considered suitable to measure the BOD up to 5 days only, and that BOD 5 or BOD 3 actually they essentially represent the carbonaceous stage of the BOD test, and they represent the carbonaceous oxygen demand. They do not represent the nitrogenous oxygen demand along with the carbonaceous oxygen demand. So, this is there. Under some conditions, if ammonia, nitrite and nitrifying bacteria are present, nitrification can occur in less than 5 days also. So, it is possible, and in the natural environment it is possible. However, during the BOD test we add some inhibitors so as to prevent the oxidation of ammonia, and if the inhibitor is not added, the BOD, which actually represents the carbonaceous oxygen demand in a way, will be at least 10 to 40% higher than that accounted by actually the carbonaceous oxidation. So, we always add inhibitor so as to minimize the nitrogenous oxidation, so as to not to add the demand of nitrogen into the carbonaceous oxidation. The results of BOD tests are reported as carbonaceous BOD or as CBOD3 when nitrification inhibitor is used. Now, this is the figure actually which represents the dependency of time and temperature for the BOD analysis, and it may be noted that BOD test is carried out either at 20 degrees centigrade. This was for 5 days, this was the earlier in standard. Nowadays it is conducted at 27 degrees centigrade for 3 days. Now, we can see the effect of temperature here. Now, earlier what we pointed out that there are 2 stages of demand. So, one stage is like up to 5 days or 6 days, we can see here the demand is there, and after that again the demand is increasing. So, the second part of demand is basically the carbonaceous plus nitrogenous. So, here in this case we can see the demand is increasing. So, this section is nitrogenous demand in the at 20 degrees centigrade, this is the nitrogenous demand. In this figure it seems this is the nitrogenous demand, and whereas the lower part represents the carbonaceous demand. So, we always represent either BOD, we report either BOD3 or BOD5 depending upon the standards which are prevailing in the respective countries. In India currently the standard is with respect to BOD3, and in this figure what we can see is that if we measure the demand BOD value for the same water sample at different temperatures, we can essentially see that the oxygen demand, the BOD value increases with increase in temperature, and this is because the microorganisms have increased their tendency to degrade the organic matter enhances, and their metabolic, all the metabolics increase with increase in temperature, because of which the BOD also increases with increase in temperature. Going further, what are the methods of measuring the BOD? So, BOD can be measured very easily by 2-3 methods. So, BOD already we have told that it is the amount of oxygen which is essentially the dissolved oxygen required for the biological decomposition of organic matter. The oxygen consumption is related to the amount of biodegradable organics. So, when any organic is present in water, this is used by microorganisms in presence of oxygen to convert into CO2. Some part of the organic matter is used for biomass growth also. Now, what we do is that we try to measure the BOD by measuring the dissolved oxygen before and after the test. So, initially what we do is that we measure the initial oxygen and then we measure the final oxygen. So, difference between both in terms of milligram per liter either 5 days or at 3 days gives the measurement of BOD. During this test what is done is that we use 2 standard 300 ml bottles which are filled completely with wastewater. The bottles are sealed. The oxygen content of one bottle is determined immediately and the other bottle is incubated at 20 degrees centigrade for 5 days or at 27 degrees centigrade for 3 days in total darkness to prevent algal growth. After 5 days or 3 days as respective temperatures, the oxygen content is again measured. The difference between the two DO values is the amount of oxygen consumed by microorganisms during 3 days or 5 days and is reported as BOD5 or BOD3. Now, these are the bottles we can see, the initial, these are the 300 ml bottle. They essentially, when we fill the water in this water bottle, sample in this water bottle, actually they, when the cap is capped, they measure 300 ml exactly. So, we keep these bottles inside this incubator depending upon the temperature for that respective number of days, and we measure the DO using the DO meter either 3 days or 5 days. We can use the titration method also for determining the dissolved oxygen. Since the saturated value of DO for water at 20 degrees centigrade is around 9.1 milligram per liter only, that means the oxygen demand for wastewater may be of order of several hundred many times. So, therefore, what we do is that wastewaters are generally diluted, so that the final DO in the BOD test is always greater than 2 milligram per liter. So, in the any wastewater sample the dilution is very necessary, and until unless we perform dilution we cannot measure the BOD correctly, because the BOD may be much higher, whereas the DO saturation level is only 9.1 milligram per liter. So, when we perform the test we cross check two things, and if any of the two things fail we consider the test to be failed, and then we have to dilute the water. So, what is done is that precaution is taken so as to obtain at least 2 milligram change in the DO between initial and final values. So, there are two conditions that have to be cross checked, that after the test is completed the final DO value should be at least 2 milligram per liter or more. If it is less than that, that means there is a possibility that total oxygen may have gone, and we are measuring incorrect value. So, considering this condition we always try to see that the final DO value should always be greater than 2 milligram per liter. The second condition is that the difference in the initial value and the final value, that should also be greater than or equal to 2 milligram per liter. If both these test conditions are satisfied, we consider the BOD test to be satisfactory, and then we report the BOD value. If any of these conditions fail, we use the diluted water for diluting the water sample, and then only we determine the BOD. Under that condition, when we do the dilution of the sample, then we use this particular formula, where DOI and DOF are the initial and final DO concentration of the diluted sample, and where the P actually represents the ratio of sample volume of wastewater taken. So, we can say that this is the volume of wastewater, okay, and divided by volume of wastewater plus volume of dilution water which is used. So, here the dilution water which is used, and generally this will be 300 ml, because we are using the 300 ml water bottle, and here the volume of wastewater is there. So, this is the P value. So, in this formula it is assumed that the diluted wastewater had no oxygen demand of itself. So, whichever diluted wastewater we use, it has no oxygen demand by itself, and this dilution wastewater is pure. Now, there is another condition which may happen, that most of the times the microorganisms may have to be added. The wastewater sample itself may not contain microorganisms. So, under those conditions we need to add microorganisms from outside, and if we have to add microorganisms from outside, so what we do is that in place of pure dilution water we use seeded dilution water. Seeded dilution water means the water which contains microorganism, and this is done so as to have enough microorganisms for carrying out the biodegradation of organic waste. So, if the wastewater may not contain any microorganism, we dilute that sample with seeded water which contains microorganism, and in this case because we are using some dilution water which may itself incur some oxygen demand. So, in that case we determine the DO level in this dilution water also. So, BI and BF actually represent the initial and final DO concentration of seeded dilution water, because they will be incurring sub demand itself. So, what we do is that we subtract the oxygen demand of the diluted water sample, and the formula, the revised formula becomes like this. So, we can find out BOD 5 or BOD 3 depending upon the number of days and temperature at which this test is carried out, and we use this particular formula for determining the biological oxygen demand or biochemical oxygen demand of the water sample. So, we have learned that the BOD can be determined by 3 methods. Under one case we do not require any dilution water, and we essentially determine the BOD value using the initial DO and final DO. There is a second case in the water sample may have to be diluted if the value of BOD is little higher. Under those conditions we use dilution water which does not contain any microorganism. In the third case the microorganisms may have to be required because the water sample may not contain any microorganism by itself. So, under those conditions we use dilution water which is essentially called as seeded dilution water, and which itself incurs some demand for oxygen. So, under those conditions we use this formula for determining the BOD value. Now, we have seen earlier that the BOD is a function of time also as temperature. So, let us model BOD using some equation so that we can determine the BOD value. If one of the values at any temperature is known, we can easily find out the value at any other temperature and time. So, this is possible. So, for modeling the BOD we assume that the rate of decomposition of organic waste inside the water sample is proportional to the waste which is left in the flask itself. Now, if suppose LT is the amount of oxygen demand left after time t, so the rate of oxygen demand will be proportional to the oxygen demand itself. So, we assume this to be first order, and thus the proportionality rate constant K is called the BOD rate constant, and its unit is time inverse. Now, if we try to solve this equation, we assume that at time t is equal to 0, the amount of oxygen demand is L0, is the ultimate carbonaceous oxygen demand, and so we can find out the L0 value. So, integrating this particular equation 1 with respect to the condition that L0 is the ultimate carbonaceous oxygen demand or the oxygen demand at time t is equal to 0. So, it is we can find out this particular equation, and at time is equal to 0 no demand has been exerted. So, BOD is essentially 0, but after some time the BOD's value will be there. Now, when we model such equation, there are two important things that have to be considered. There is always the BOD value, BOD ultimate demand or the oxygen demand left is they are essentially 0, they are essentially same, and at any time the amount of oxygen demand which is represented by this equation where L0 or BODU, there are two terms which are related. So, we will explain this using a figure. Actually, this is the figure suppose, and we want to measure the BOD. Now, BOD if you want to measure, it will be like suppose for 5 days only carbonaceous BOD we are measuring. So, the BOD will increase like this. Okay. So, at any time t, here this is the equation time t in terms of days, this is there, and this is this curve actually represents the BOD at any time t. Now, opposite the oxygen demand will always be represented by this equation where L0 is the initial oxygen demand which was very high and which will go on decreasing depending upon the oxygen demand left. Okay. And similarly, the BODU represents the ultimate oxygen demand, the demand of BOD which will be there after ultimate time or infinite time. So, we can see from this figure, and this represents LT. Now, we can see from this figure that either L0 this one or BODU, they are essentially same, that was written earlier, and they are essentially equal to LT any oxygen demand left and the oxygen demand which has been incurred already. So, this is BODT. So, this is the ultimate formula which represents this. So, from this figure we can find out that we can find out the BODT by subtracting the LT value from L0. So, the equation for BODT from this represents the BODT is equal to L0, or we can see BODU minus LT, and if we represent LT itself. So, this is L0 minus L0 e raised to minus KT, and that means L0 1 minus e raised to minus KT. So, this is the equation which is given here. So, at any time L0 or BODU, they are equal to BODT plus LT, that is the amount of DO demand used up at any time and the amount of DO that could be used up eventually. So, we have already derived the equation. So, we can model the BOD using this equation. Now, in this case there is a parameter with respect to K, the K which is represented by the BOD rate constant. Now, this BOD rate constant K is a function of temperature. As temperature increases, we have seen the metabolism increases and utilization of DO also increases, therefore, K is a function of temperature. So, K at any temperature T can be written by this equation. Combining both equations together, we can always write the BOD in terms of temperature and time. Now, the K at this is the K at 20 degree centigrade. Remember, the T value given here is always in degree centigrade. We have to write the value in degree centigrade, we cannot represent by any other Kelvin or Rankine etc. Now, the theta value is an empirical constant and is a function of temperature. So, generally like in the range of 4 to 20 degree centigrade, theta can be written as 1.135, and at between 20 to 30 degree centigrade 1.056. There are different theta values depending upon the type of wastewater also. So, but generally they will fall in this range 1 point something. So, this is there. Now, for simplicity we can write another trick we can use is that we can always remember the BOD T at any temperature is a function of this L0 1 minus e raised to K at temperature, whatever temperature it is being measured, into time. So, this is the good formula to remember, and where KT is equal to this. So, through this formula we can use the T term is also coming, where the temperature at which the K value has been determined. So, we will try to solve some question so as to further understand how to go ahead in determining the BOD values. The 6 ml of wastewater is diluted to 300 ml of distilled water in a standard 300 ml BOD bottle. The initial DO in the bottle is determined to be 8.5 milligram per liter, and the K value is known to be this. So, K value is given, but there is another thing is given that DO after 5 days at 20 degree centigrade is found to be 5 milligram per liter. So, we have few things which are given here. First thing is that we have been given the dilution factor, because we have the value of 6 ml of wastewater is diluted to 300 ml of distilled water. So, we have volume of wastewater plus volume of dilution water, and this is given to be 6 ml by 300 ml. So, this is there. So, this is the dilution, P is given here. Now, the DO initial is also given, DO initial is 8.5 and DO final is, this is milligram per liter, and DO final is 5 milligram per liter. So, if we use the formula earlier which was given, that BOD at any time, since this is 5 days, so this is 5, this is equal to DO initial minus DO final upon P. So, the same formula is given here, in place of P it is written in terms of volume of wastewater plus dilution water. So, if we use the formula we can find out that BOD5 is 175 milligram per liter. Now, we have to compute the ultimate BOD, and already we know this is the formula. So, sometimes in the formula in place of BODU it is L0 which is given. In the previous case we can see here that here L0 is given, but it is L0 or BODU both are same. So, there is no difference. So, this is the formula which is given here, and using this formula we can find out the BOD5 is equal to the K value. Since it is given, we can find out the BOD5 to be 256 milligram per liter using this formula and after putting all the values. So, thus the maximum amount of oxygen demand that will be incurred by this wastewater sample will be 256 milligram per liter. Now, there is another thing, another question is given here. The BOD6 of a wastewater is determined to be 400 milligram per liter at 20 degree centigrade. The K value at 20 degree centigrade is known to be 0.23 per day. What will be the BOD8 value? Suppose the tests were conducted at 15 degree centigrade. So, we have the BOD6 is given already at 20 degree centigrade and K value is also given. So, using this, so earlier I had given this particular formula where the temperature was also written. Now, we use this particular trick to find out the value of ultimate BOD. So, BOD6 at 20 degree centigrade is given to be 400 milligram per liter, K20 is also given. So, if we keep both the values BOD6 and K value, we can determine the ultimate BOD, and that will be 534.5 milligram per liter. So, once BOD has been determined, we can again use back this formula to find out the BOD8 at 15 degree centigrade. Now, we have to find out the BOD8 at 15 degree centigrade. So, that means we should know the K value also at 15 degree centigrade. So, because we have to ultimately use this formula. So, if we have to determine the 15 degree centigrade value into 8. So, for this we have to find out K15. So, we can find out the K15 using this particular formula, and the K15 value will be 0.23 into theta value is given, suppose it is given as 1.047, and then we can find out 15 minus 20 degree centigrade, and through this we can find out the K15 value, and once K15 value is determined we can find out the BOD8 at 15 degree centigrade, and this will be 410.6 milligram per liter. So, this way we can find out the BOD values at any temperature and at for any number of days. So, this formula gives lot of ideas with respect to converting the BOD values from one value to another value at different temperature and time. So, today we have learned regarding the BOD, everything was described with respect to BOD. In the next lecture we will try to learn the difference between BOD and COD, because we have learned both COD as well as BOD, and then there are other parameters also like total organic carbon, then theoretical oxygen demand and the difference between the two. So, we will continue the wastewater characterization aspects with respect to biological or biochemical parameters. So, thank you very much for today's lecture.